Recording. Welcome to ICE Education, the only education that matters. By the way, if you guys stream or do whatever, you can use OBS Studio, the what I used to record my class. So you can use it for whatever you want to do. And if you want to do classes like me or cheat something, you can also use Microsoft Whiteboard. It's quite good, it's not bad. So yeah. Okay, my good guys. Question 19 from the lecturer's note. It actually says that an Episaki gear trend consists of a central sun gear S, three equally spaced in planet gear P. This basically something like this that we did yesterday. They said, and the surrounding ring gear or annulus A. The planet gears simultaneously engage with both sun and annulus gear and are mounted on a common carrier arm. Okay? Now, they said in this configuration, the sun gear is connected to the input shaft and rotates at 400 RPM. The system uses the following gear specification. The sun gear has 20 teeth and each planet gear has 40 teeth, enabling smooth torque transmission within the gear train. If annulus rotates freely, determine the speed at which must rotate so that the carrier arm output is this. Now, they say if the annulus is fixed and the input shaft continues to deliver the power of this and that, and the system operates in overlay what calculate the torque transmitted through carrier arm. Mr. Tapelo, I read your suggestion yesterday when you told me to record the videos and put on my YouTube channel. So I will definitely do that. For the remaining of the question, I will solve on my own and I will put on my YouTube channel. I don't know if that's gonna be an advantage for you, because I think if I put it on my YouTube channel, everybody will have access to it, but you guys paid me for that. So you can tell me right now what you guys think about it. What do you think about it, guys?
You can just send the solution to us, man.
Okay, sending the solution to you, it means I can make the video private.
That's not a problem.
I think that's what I need to do, just to consider the fact that I'll explain what I'm doing. Where is Daphne? Daphne? I miss Daphne. Where is she? This is nice. Daphne? Where is she? Mr. Isam? Where is Daphne?
Yeah, you're asking the wrong person.
Who should I ask, my friend? Mr. Isam. Daphne is your colleagues. Oh, what's going on? What's going on here? I want to move this thing here to make them three. But anyway, let me just draw it. Mr. Gordon, where is Daphne?
How will I know?
But you are the friend, my G.
I don't know.
She's not doing mechanics, man.
Oh. So how do you know, my friend? Because everybody doesn't know. You have to tell us the truth, my friend. How do you know?
Ish.
How do you know, my friend? Yeah, that's fine like that. How do you know? So you are Daphne's bestie.
Just a friend, not a business, just a friend, man. Just a friend.
You can say the truth, my friend. We won't judge. We'll just listen. We won't judge. Okay, guys, this is literally what is here. But let me see if I can group them. Control G. That doesn't work. Did you know that you can do all this using PowerPoint? Even Excel. I've seen people using Excel doing crazy things that AutoCAD does. Some people are good. Anyway, guys, let's come back to our business. I'm gonna use the pen for the first time. We're gonna see how it is, and you can. I think it's gonna be better because actually, when I use the pen, I'm writing with my own handwriting. Let's say I write Chi over something. I'm actually writing it, not with a mouse. So it should be fine. Now, okay, now what is saying here? They said an epicyclic gear train consists of a sun. Remember, guys, the sun is the one in the middle here. A gear sun is this one here. 3. If you watch the yesterday videos or what you watch this is similar to what was given yesterday. I do believe that this is even easier. Now, they say that 3 equal space planet gears. These are the 3. 1, 2, 3. They are spaced like this. And surrounding the ring and surrounding gear or annulus. The surrounding gear is the one on top, surrounding everything. They call it surrounding gear or annulus. That name is so weird. Now, they said the planet gears simultaneously engage with both sun and annulus. So what are the planet gears? Remember, it is 1, 2, 3. So simultaneously, it's busy engaging with what? With the surrounding and the sun. That's what's happening there. And they say the sun gear is connected to the shaft input of 400 RPM. Now, they say it again. The system uses the following gear specification. The sun gear has 20 chief. If you remember on the yesterday question, we were asked to solve for the number of chief. But the good thing here, the number of chief is provided here. But anyway, even if it is not asked, remember, make sure that you have the number of chiefs of all elements that you have on your problem. You need to make sure of that. So, what is happening? And each planet gears has 40 chief. So each of these small circles, they've got 40 chief, enabling smooth torque transmission within the gearing train. If the annulus freely rotates, determine the speed at which it must rotate. So basically, you want to find out what is the speed of the annulus, the speed of the guy outside here. Must rotate so that the carrier arm output shaft is 30 RPM. And if the annulus is fixed, what there? Let's solve the first question first. Okay, guys, whenever we have something like this, what's the first thing to do? The first thing to do is to draw what we have. If you can see here, this is basically. Let me use the pen. I think I'm gonna be a bit slow with the pen, but I'll be fine. Hey, I'm kind of slow. This is the carrier. What am I saying? This is the annulus, I mean, and this is the drawing from this statement here. All of this is referred, for those who were here yesterday, to the example in the textbook. If you have not seen it, there's a video on YouTube that has been posted yesterday, And remember, whenever I post a video, I will not send you the link. All you have to do is to click the notification button for you to receive it when I post something. Because if you don't click, you will not know that I posted. So, and yeah, it is what it is. Now, what do? We can come here. We know that inside here we have the sun. This one here are the space plane. They call it P. And the guy outside here is the annulus. This circle here. So basically what is happening, if you read somewhere here, they talk to you about the arm. The arm is the center. This thing is actually in the center of the circle. It's because I have not drawn it accurately, but this actually means the arm is acted at the center here. Now, what is happening, my guys? First thing that we need to do is to plot the table. I don't know if I'm making sense. And the table, we know how it works. I'm just gonna draw it again here. For those, if it is the first time for you to see it, this is what we'll be having. Ish. I think I'm better with the mouse than the pen, so but I need to get used to it with the pen. Now, what you do is you write all elements that you do have. You have S, you have P, and you have A. So let me show you how it is done. Hopefully there's an example. What was the example of yesterday? Oh my goodness.
It was 13.20.
13.20.
Yeah.
Okay. They called the arm. They call it C. I don't know if we should also call it C. It doesn't matter. But let's just call it C and C. Now, what you do here, you write all the element. You have arm. Let me just write it like this. Arm C. You have element. You can call the sun S. This pen. Anissa. Sorry if I'm slow. I'm just trying to get used to this pen. And we also have P. And we have the annulus A. Now, what do we do with this table? What's the aim of this table? The aim of this table is actually to get what we call the total motion. From the total motion, we can solve whatever that we need here. So what we do here, the table will always be the same. When I say the same, you will always have 4 steps for all the problem. Look at this problem. How many steps do you have? 1, 2, 3, 4. If you move to the next one, how many steps do you have? 1, 2, 3, 4. You only have 1 step. 4 steps. The most important things when you do this thing, guys, it is your first line. If you messed up on your first line, you messed up on everything. I'm pretty sure you guys know what I'm talking about. I think that works for everything in life. If you messed up on your first everything, I don't think you stand a second chance, unless I don't know. But yeah. So basically, we take the arm fixed. Why do we choose the arm fixed? Yesterday I have explained it. You always need to fix a point before you rotate any before you rotate any gear. An arm fixed, we always fix it because we take it as a reference point. You cannot see. I took an example of a ball yesterday. I don't know if it was making really sense, but I think it does. Before you kick the ball, let's say the game starts, you fix it first. You put in the middle and then you kick. That's what's happening. And if you want, guys, if you want, you can try to know all these steps here. Look at this example here. They said arm is fixed and we rotate to whatever positive. It will always be like this. So you already know what you are solving. So I don't know how to explain it further. but the statement, they are not changing. Now, what is happening, guys? If you remember yesterday, I've said in this topic, when we talk about anti-clockwise, it means talking about what? Positive. Clockwise, it means we're talking about what? Negative. That's what's happening here. So what do? Arm fixed, it means the speed at the arm there is 0. So the first condition is we always fix the arm. That's the first condition. Now, what is the second condition and delay? Between what you have here, you need to give something a direction. You need to come and say, okay, if I give A this direction, what's gonna happen to the rest? Because those gears, there are a lot. I don't know if you have seen them on videos on YouTube or somewhere. There is always a driver and a follower. There's always someone leading and there is always the rest following. This is basically what's happening here. So if we do come here in this figure, we give the sun positive direction, it means it's going in the anti-clockwise direction. And yesterday I've also stated again, if you do have 2 gears, 1, 2, let's say 1, 2, this is not looking nice. It's 2 practice makes better. I was used. If you have 1 like this, we have 2 gears like this, 1 and 2, and you do know that these 2 are touching each other. They call it gearing. If they say 2 gears are gearing, it means they're touching each other. Or they say they mesh together, it means they are touching. So as long as this 1 and 2 are touching each other, they have what we call a velocity ratio, where you have, let's say, T1 over T2 to be equal to N2 over N1. Now, what is happening here? What is T1? What is T2? T1 stands, the T here stands for number of sheaves. The N here stands for the speed. I'm repeating myself, it is really important to know that. So what's happening if I come and give T1 a positive direction? T2 will go the other way, clockwise. So because of this, remember the sign convention depends on the follower. If my follower is moving clockwise, it means on my ratio here, I need to have the presence of a negative sign. Any question, guys? Please talk to me. Talk to me. Talk to me. Okay, I guess we are fine. Since you're not talking, I do believe that we are fine. Okay, what do we do here? On this system here, we are choosing to give the sun positive direction, like moving in the anti-clockwise direction. And what did I say? I've said that whoever is touching the sun here will have what we call what? A speed ratio. Let's say, for instance, sun is touching P, any of the P here, it doesn't matter. If it's touching P like this to be anti-clockwise, this one should go here, clockwise. This one also here should go clockwise. This one also should go clockwise. Any question, guys? Kiddos. Kiddo.
Yeah, I'm okay.
Hey, your name is funny, Maji. I just like it though. Kiddos. Okay, what we do is, my friend, when we give a direction, we always give the smallest speed that we know. What is the smallest speed, Mr. Kiddos? It is 1.
What is the smallest one?
The smallest speed that you can give to something. The very smallest one. I don't think your car can run at 1 kilometer. 1 kilometer. You're gonna be stopped. So now we come on this system. We push our system with a positive 1. That is the region under your condition. They always write let's give 1 revolution in anti-clockwise. Anti-clockwise, just to specify that it is positive 1. That's what it stands for. So literally what is happening when you give it a positive 1, it means when you come here, S here should be, the velocity at S here, the speed at S should be positive 1, because you chose it. Now here's the thing, you might ask me, why don't we come and give this velocity in the clockwise direction? What's the reason, Mr. Kidos?
Hey, why you saying what? Why don't you what?
What's the reason we are choosing to give positive what? Why not negative 1? Why not taking it in the clockwise direction?
Why, Vil?
No, because there is no reason, my friend. That's how it is.
Mm.
Nah, I'm kidding. Like, there's no actually reason. It's more or less like this. When you have a Cartesian planes, who told you that this is plus, this is plus, this is minus, this is minus? Nobody. You can reverse it. You can put plus here, minus here, minus here. That's how good science is. But now, for consistency, because we all do math all over the world, we have decided to stick to what we see here, plus, minus them. So when it comes to gear, to keep the consistency in the solution, we always give it a positive 1. There is no actual reason. You can actually give it negative, you will still get the same answer. But for the sake of consistency, to keep science as simple as possible, we always give it a positive 1 direction. And it's easier when it is positive. Now guys, can we move to the speed at P? How do we get the speed at P? To get the speed at P, what do we have? We know that S and P are touching each other. You can see S and P are touching each other. Definitely you have the speed ratio. So I can come and write this side here. Oh, what's going on? I can come and write this one here. TS over TP to be equal to NP over NS. Do you guys agree, guys? Perfect too. Somehow I don't like this online thing because I can't see you, but today I had to do it online. Do you understand, guys? Guys, talk to me, please talk to me. We did something like this yesterday. Can I move?
Yeah, it's fine, so you can move.
Okay, thank you. Nomsa? Nomsa beauty.
Yeah, I understand.
Oh, you understand, eh, beauty. Now, now, what is happening here? You can make NP subject of the formula because that's the speed that you are looking for. NP will be NS multiplied by what? TS over what? TP. Now, I want to ask you something, guys. What is the speed of NS? What is the speed of NS, guys? Ish, perfect. Anyway, it's fine then. Guys, what is the speed of NS, guys? Can you hear me?
Is it 1?
You have to tell me if it is.
1.
Yeah, it is 1. Why is it 1? Remember, you have chosen it here. You picked it first. It's the first assumption. You said S is equal to 1. So what is NP here? It is simply TS over TP. But in this again, just like yesterday, there's something wrong here. What is wrong here, Mr. Isam?
It's a negative sign.
Yeah, there have to be a negative sign because the driver is going in the clockwise direction. So because of that, here on the expression of P, it's gonna be minus TS over TP. Easy as that, guys. Now, when we zoom in here, when it comes to the annulus, this one outside here, which one is driving it? What's the direction? Which direction will it go, my friends? P is going clockwise there. Therefore, this one will go anti-clockwise. Now, what will be the speed ratio? You can confidently come and write NS over NP to be equal to TP over TS. Now, what is happening? You know what is NS? NS is 1. So, what am I writing here? I think I'm rewriting what I wrote there. Now, the speed ratio is between the annulus A and P, not NS there. So, what's happening here? We will have NP over NA to be equal to TA over what? TP. Now, what are we looking for? We are looking for the speed at A. So, NA will be, if I can cross multiply, you'll have TP TA multiplied by NP. Now, what is happening here? In this ratio here, are we going to have a negative? No. Why not? It's because the follower is going in the positive direction. It's just going to stay the way it is. Now, but what's happening in this expression here? You also do see that in this case here, that you've got the presence of NP. So what is NP? You found NP. NP is minus TS over TP. So you can continue here by saying that TP over TA is equal to minus TP TS. This is equal, eh? Don't confuse with minus. Minus TS over TP. So you find out that TP cancel TP. So at the end of the day, what you have as expression of NA is basically minus TS over TP. So you can confidently come here and write here that you do have minus TS over TA. Any question, guys? Yes, who's joining now? Who's joining now this late? Any question, guys? Mr. Dangale.
Hey, Shah, man, I didn't have network, man.
But you're in the Val. In the Val, we have network, my friend.
Where I am, the Wi-Fi wasn't operating, you see. Yeah.
Okay. The Val is the best city in South Africa, my boy.
Yeah, where I am, like, the Wi-Fi wasn't Wi-Fiing.
Okay.
So, yeah.
Okay, let's get back to the table, guys. When we are here on the table, so it's looking skew, eh? What is the next step, guys? We multiply everything by x revolution. If you multiply by x revolution, x times 0 gives you 0. X times 1 gives you x. X times this gives you minus x TS over TP. X times this gives minus x TS over TA. Now, yeah. This is what is happening. So now, here, you can see the step, what they write there, to see what to write, but it's repetitive, it's the same thing. You always have to have the y revolution. And the last and not the least, it is what is called the total motion. Total motion simply means the total expression of the speed that you'll be using in your calculation. For the total motion, you do have y plus this, which gives you this. X plus y, it gives you x plus y. This one give you y minus x ts over tp. Now we have y minus x ts over this ta here. So what does it mean? It means like now, if you want to write the expression of ns, it's going to be x plus y. That's what it means. Expression of np is going to be y minus x ts over tp. That's what it means. Expression of speed a, na, is going to be y minus x ts over ta. That's what's happening. So, Mr. Masheshe, is it Mr. Mashele? Sheshe. What team are you supporting tonight?
What are you saying, my man?
Nah, I was asking, what team are you supporting tonight?
Nothing.
What team do you usually support?
Real Madrid. I support Real Madrid and what's this? Man City.
Say hi to your girlfriend, my friend. I see she's there.
Yeah?
Say hi to your girlfriend.
Yeah, she said hi.
I can hear you, my G. And you don't want to do online class. Imagine online class you are attending, but you are next to your girlfriend. Isn't it nice? My friend?
Yeah, it's nice. It's nice.
You see?
It's nice.
But
nice.
it's not nice for Tapelo. He's alone.
Why is it not nice for you?
He's alone, man. There's nothing wrong with being alone. I'm just saying. I'm also
What time is the game starting?
9 p.m.
9 p.m. So later on you can have steam plant before the game, ne?
Oh my G. Kick game time here. I'll be drinking there by Capitos.
It's fine.
You see now.
But let's continue, man.
Let's continue. This guy, people are. No, I'm kidding. We'll meet. I'm not going anywhere.
Sure.
Now, okay, what is the question asking here? After you do your table, this is where you start solving. The question is saying, if the annulus rotates freely, determine the speed at which it must rotate so that the carrier arm output is that. What is the carrier arm? Remember. Hey. Okay, it's the calculator. What is the carrier arm? The carrier arm is C here. The one that we call as fixed point. Now, they say the carrier arm output is 30 RPM. What does it mean, my friend? It simply means the value of Y here. Because remember, the carrier arm, the speed here. It simply means Y. What's going on? Y is equal to 30 RPM. So here's the thing. If they don't say clockwise or anti-clockwise, you take it as it is. But if they say 30 RPM clockwise, you know this value is negative. If they say anti-clockwise, you know it is positive. So now, if we go to Y, so definitely we can get X, because you need X and Y to solve for NA. Remember, this is NA. You need Y and X. But we've got Y. How can we get X? If you read again on your statement, there is an information provided again to you. They said what? The sun gear is connected to the input shaft that rotates. So the gear is connected to the shaft. So what does it mean, my brother? If that shaft goes at 400 RPM, what do you think would be the speed of that gear, my friend? Hello, Bafetu. Okay, Mr. Kiddos, if you are running at 12 kilometers, no, you can't run at 12 kilometers. You are not that fit. 4 kilometers per hour, and you are holding someone who's running like, what's the speed do you think that person will be running, my friend? You guys will be running at the same speed. Okay, if you want to see what I'm saying, oh, I can do things like this. I'm pretty sure in our whole life we've seen car 1 and car 2. Let's say this guy was driving and whatever, his tire got damaged and he requested for help. Now, this guy is pulling him. If this guy is moving at, let's say, 60 kilometers, what do you think will be the speed of this guy?
It will be the same.
It will be the same. Literally, this is what's happening here. They say the sun gear is connected to the input shaft and rotate as this. So it means the speed of that input will be the same as the speed of the gear. So it simply means when you come to NS here, you can come and say that NS is equal to 400 RPM. Now remember, you've got NS, which is 400. You don't have X, but you got Y, which is 30. So what is X, guys? Which is what? 3? Do we agree, guys? Hello?
Yes.
Now, if we get X and Y, do we also agree that we can solve for NA?
Yes.
But in this thing here, what do you think is missing again here? The number of chief of A. Do you guys agree? Because we've got Y, we've got X, we've got TS, but we don't have TA. How do we get TA, my guys? We did something like this yesterday, guys. The way to solve TA, you create a radius relation here. Remember, this thing is actually placed at the center of the circle here. Now, A is the analysis outside. How do you reach A from the center? You first complete this distance. I think this thing is too heavy. Let me make it light. You first complete this radius here, which is RS. You also complete this one, which is what? 2 times RP. So basically, for you to get the number of chief of A, you can simply come and write like this. You can say RS plus 2 RP is equal to RA. Remember, this radius here is simply represented by number of chief. So you can simply say TS plus 2 TP to be equal to TA. I don't know if you see it, guys. Do you guys see it? Any question, guys? Any question, guys? We have checked.
No questions.
Yes, we have found out that TS plus 2 TP give us TA. So what is TA? If you read again in the equation, everything was provided. On the example that we did, we were asked to solve for all the number of chief, but in this case, we were given the number of chief of the sun gear, which is 20, number of chief of the planet gears, which is 40. So, what is this thing? TS is what is that again? 20, ne? Definitely we can conclude that TA is what? 100. No, it's number of chief. It's not like it's a number. Now, what is happening here? Now that you've got everything, you can solve for the speed NA, guys. You can literally do it. You know NA is 1 minus X TS over TA. You also know what is Y. You know y is 330. You know x is 370. What is TS, guys? TS is 20. TA is 100. When you do this, what is the speed of NA, guys?
Negative 44.
Something is off. Something is off. Why is this speed negative? It can be negative though. It could be. There's nothing wrong.
Is it
It's just say that
because of the direction?
it's just when I say that it's going on the clockwise direction.
Also, the negative is just showing that like
Clockwise
the
direction,
direction the motion taken.
Where's this pen?
Okay.
You got negative 44, right? In other way, you can just say 44 RPM and you write clockwise. Yeah. Now, this is what you're supposed to do there. So what is next here, guys? The next thing they said, if the annulus is fixed, what if this thing is English? If the annulus is fixed and the input shaft is this, and the input shaft delivers this of the power at 400, and the system has overall efficiency of this, calculate the torque transmitted through the carrier arm. Okay, guys, first of all, when they say the annulus is fixed, what comes in your mind, my guy? Where you are sitting there in your bed, where I want to say in the understanding way. Do you think you are moving? In which position are you?
Stationary.
You are fixed, right? You are stationary or you are fixed. It means when you are fixed, you do not have a velocity. You only have a velocity when you move. Are we together? So first information here, it's not really important in this case, but just important to know. It simply means in this expression here, NA is 0, but it's not really affecting the question here. In this question here, let's read, guys. They said if the annulus is fixed and the input shaft continues to deliver 5.5 kilowatt power at this speed, okay? Now, and the system overall efficiency is this. Calculate the torque required. Calculate the torque required through the carrier arm. Guys, what is the carrier arm? If you read here, they said the carrier arm has the output rotating shaft. When it has year of efficiency, what is the efficiency, guys? Just let me just say a real life. How do you define efficiency, bro? Don't think about it too much. In simple words, what is efficiency? Guys,
Performance.
it's your performance. Let's see, you are preparing for the test. You gave this amount of time. That's your power in. Now, the result that you get is your power out. Now you want to check your efficiency, how efficient you were. What do? You take your power out, you divide over your power in. Whatever you give, it will give you the percentage of how you've been invested in this project. For instance, if you invested yourself 100%, let's say you've gone through everything, you've studied hard, you go to the test, you get 100. It means your efficiency is 100%. When you take power output divide by power input, you get what? 1. But let's say you prepare 100% and you go get there 75. You take 75 divide by 100. Whatever you get there will show you how efficient you were to the work that you were doing. So in this case, we have two. We have the input shaft, which is the power disk, and we have the output shaft, which is attached to the carrier arm. And we have an efficiency without even thinking. By definition, I can confidently come and write first. Efficiency will be power out over power in. So what is power, guys? Power is torque times W. We've done that in terms of machine, guys. Do you remember? Now, if you are looking for the torque of what again? Is it the torque of the input? Ah, parfait. The torque transmitted through carrier. So it's the torque of the output. So what I can do here, I can make power output subject of the formula. It will be efficiency multiplied by what? Power in. We have power in given. Now for power output, I will write torque times W to be equal to N power in. So definitely the torque output, let me call it torque out, is simply going to be N multiplied by power in, everything divided by W. Now what is the speed here? The W here can simply be replaced by N. What is the speed of the carrier arm? It is 13. Any question, guys? Hello?
No question.
Yes, okay, my friend. But why would they give this information? Okay, that's just... So what do you get here? If you want to get the torque output here, guys, you have the efficiency. 88%, 0.88 times 5.5 times 10 to 3. Remember, W can be replaced by N, which is 30 times 2 pi over 60. If you do this, you'll get that torque out. You should get it. So please look at the video that I posted yesterday. You've got more explanation on what I just did now again there. It is there on the YouTube channel. Any question, guys?
No question.
So what's next? What's next? What's the name of Mr. guy? Mr. Tapelo. What we agreed with Tapelo is I will make 2 recordings on my own, like this, and then I'll give it to you. And you will see if you win If you're winning, if not, ask question on the YouTube so that I can have more comment. I will reply.
Oh, so basically now the class is dismissed.
Nah, not really dismissed. We're gonna resume for strength. You said for Steam.
Team plant right now.
No,
But for mechanics, shy.
no, it's not Shaile now, my brother. I'm going after an hour. I'll do the recording and send to you. I'm just going to town.
Okay, I'm asking for Steam plant. Steam plant will be late.
Yeah, before the game, Car 5. It has to be an hour or two because I need to.
No problem, my brother. Okay, it's fine. Then you will send the things later on. We will be waiting for the recordings then.
Yeah, I'm just going to town, come back and record for you.
Sharp.
Sure.
Ah, yeah.